Welcome back to my channel. Today we learn about the circle theorem. Okay, let's start with the one theorem. Central angle is twice of inscribed angle standing on the same arc, or inscribed angle is half of the central angle. We have already understand about the central angle and inscribed angle. Today we are going to see the relation between them. Okay, look at here. This is inscribed angle, which is standing on the arc BC, and here is the central angle, which is standing on the same arc. Now remember that if the central angle and scribe angle are standing on the same arc, then remember central angle is always twice of the scribe angle. Or you can even say that scribe angle is half of the central angle. Look at these two figures. In all the figures, you can see the central angle and the scribe angle are standing on the same arc BC, right? So now we can just write like this way. Angle BAC is equal to half of the angle BOC. Or you can say that BOC equals to twice of BAC. Remember, this will happen when the both the inscribed angle and the central angle are standing on the same arc. Okay, look at the next theorem. Inscribed angles are standing on the same arc are equal. Now, look at here. This is the inscribed angle, okay? And this is another inscribed angle. Look at this. Both the inscribed angles are standing on the same arc, that is BC. So they are equal. Here, angle BAC is equal to BMC. Look at this another figure. Here also you can see this. Both the inscribed angles are standing on the same arc BC, okay? And here, there's so many inscribed angles you can see are standing on the BC, right? In the first two figures, you can see angle BAC is equal to BMC. Both are the scribe angles standing on the same arc. Now see in the third figure, it is a BAC is equal to BMC is equal to BNC. Why? Because they are all standing on the same arc BC. So remember, whenever the inscribed angles are standing on the same arc, they will be always equal. Now look at this problem. Now we are combining the concept of the inscribed angle and central angle relation here. Both the terms we are applying here, okay? Now we have to find here the angle ACD, which is X, right? Now, before you find any angle in a circle, just try to understand that the angle is standing on which arc. For example, here you can see ACD is standing on AD, right? Now we must find out the any other angle which is standing on the same arc, AD. And it is clearly seen that angle AOD is standing on the arc AD, right? And angle AOD is a central angle, whereas angle ACD is a inscribed angle. So inscribed angle and a central angle, if they are standing on the same arc, the relation will, you already know that, right? So the central angle is just twice of the inscribed angle, isn't it? So in order to find the angle ACD, we need to find out the angle AOD. And how can we find the angle AOD? The given angle is 120 degree and it has a relation with the AOD, right? So you can see it like this way. Angle BOD plus angle DOA, that is equal to 180 degree. Why? Sum of linear adjacent angles, right? Now we'll find here BOD is 120 degree plus angle DOA is equal to 180 degree. So angle DOA is equal to 180 degree minus 120 degree. So it gives you that angle DOA as a 60 degree. So we have found DOA, right? And DOA is the central angle which is standing on the arc AD. On the same arc AD, you can see angle ACD is also standing. So what's the relation? We can see here. Angle DOA is equal to twice of angle DCA. Why? Central angle and scribe angle standing on the same arc. So here DOA is a 60 degree and is equal to twice of angle DCA. So what's the value of DCA? It is equal to 30 degree. Okay. Now let's look at one more. That's a theorem. Another theorem. Okay. Angle in a semicircle is a right angle. That is 90 degree. You know that. Look at the circle here. It has a diameter AC and diameter divides the whole circle into two parts, right? In the semicircle. Now you can see here this angle which is formed at the semicircle is this is equal to 90 degree. So here angle B is equal to 90 degree. You can see two more figures here. Okay, in both the figures you can see the angle formed in the semicircle. And remember, angle in semicircle is always 90 degree. That is, in each case, angle ABC is equal to 90 degrees. So don't forget this property also. Okay, now let's move to this problem here. Now, closely look at this problem. How can we solve this problem here? Now we have a three different concept here. First, central angle and the inscribed angle relation. Central angle is twice of inscribed angle if they are standing on the same arc. In the second, we learn about the inscribed angles standing on the same arc are equal. And in third, we learn about the angle in semicircle, right? Now, Before we find the value of the x here, we have to find out the angle, this x, that is angle DOC, is standing on the arc DC. Now we must look that is there any other angle which is standing on the same arc, but it seems like there are no angles which is standing on the same arc DC. And now you can see the angle is 60 degree, which is just outside of the circle. So remember, outside of the circle, we are not able to use any of the theorem here. Okay, so we can use the theorems only inside the circle, circular theorem. We can use it inside only. So what can we do here? So there's one idea. We can just join the B and D. Okay, what will happen when we join B and D? Now we can form the semicircle, angle in semicircle. Did you notice that? Angle ADB will become a 90 degree. We can just simply say here, angle ADB is equal to 90 degree. Why? Angle in semicircle, correct? Okay, now what can we do next? We can use this relation. Angle ADB is equal to, that is angle DBE plus angle E. Why? We know that exterior angle is equal to sum of non-adjacent interior angles. Look at closely, angle DB. In triangle DBE, we are just taking angle ADBE as exterior angle, right? Now here, what is the value of the ADB? That is 90 degree, and dB is, we don't know the value of the dB, and the angle E is 60 degree. Now with this one we can find angle dBE is equal to 90 degree minus 60 degree, where you can get angle dBE is equal to 30 degree. Now the question will arise here, what is dBE? Actually I can say, even that for the angle dBE, I can say this angle is angle DBC. Okay, dBE and the DBC both are the same. Now you must be wondering, you must be now thinking that why we are finding this angle DBC. Look at the arc of DBC. Do you think that our angle DBC is standing on the arc DC? Yes, obviously this angle DBC is standing on the arc DC. And on the same arc DC, you can see the angle DOC, right? Now that is DOC is the central angle and DBC is the inscribed angle. So what's the relation once again? We can write here, angle DOC is equal to twice of angle DBC. Okay, what's the reason? Central angle and inscribed angle standing on the same arc. So what is the value of the DOC? It's X. And what is the DBC? We already found it. That is 30 degree. So 2 times 30 degree gives you, that is 60 degree.